Hello students, welcome to online audio video lesson. Myself Mrs. Rajeshwari Mahapatra, Mathematics teacher for Standard 10. So students, today we are going to discuss the third chapter of Mathematics-2, that is your circle chapter. Already in the problem set, the first part already in the last video I have explained. This is the second part of the problem set 3. So let's start with the problem set 3 of the circle chapter, that is question number 7 to 10. In this slide we are going to discuss. In the adjoining figure, you can see the figure diagram. Circle with center x and y touches each other at point z. So a secant passing through z intersects the circle at points a and b respectively. Prove that radius xa is parallel to radius yb. So we have to complete this proof. So here given x and y are the center of circle. Centers of the circle, you can see x and y are the center of the circle. Now in the construction part, draw segment xz and yz. So xz and yz join. Now by the theorem of touching circles, points x, z and y, these 3 points are in collinear. So angle XZA and angle BZY both are vertically opposite angles. So these two angles are congruent. Now angle XZA equals to angle BZY. We will take it as A. Go to equation 1. Now segment XA, segment XZ both are congruent. So radii of the same circle. That means here also angle XAZ is congruent to angle XZA. Why? Because of isosceles triangle theorem. Similarly, we can say that X segment YB congruent to segment YZ, that is radius of the same circle. So here again the angle related to YB, segment YB opposite angle will be what? Angle BZY equals to angle ZBY equals to A. That means it's a isosceles triangle theorem only. So from equation 1, 2 and 3, what we can conclude that angle XZA equals to angle ZBY. Therefore, radius XA is parallel to radius YB because the reason behind is alternate angle test. Now come to the next question. You can see the diagram. So the construction part you have to join this Z, X and Y. So here in the adjoining figure, circles with the center x and y touch internally at point z. Segment BZ is the chord of the bigger circle and it is intersect smaller circle at point A. So prove that segment AX is parallel to segment BY. So here x and y are the centers of the circle. So we have to prove AX is parallel to BY. So in triangle XAZ, what is there? XA is congruent to Z, XZ, XA is congruent to XZ, radii of the same circle. And if it is radii of the same circle, this is two sides of the triangle. So the opposite angles will be congruent because of isosceles triangle theorem. So same way in triangle YBZ also you will write, that is YBZ. Here also YB and YZ is the radius of the same circle. Again isosceles triangle theorem you will apply and angle YZB is congruent to angle YBZ. So from equation, this is here equation 1 and this is equation 2 you are going to substitute from equation 1 and this equation. Both the equation you can take and we can write angle XZA congruent to angle YBZ. Therefore, angle XAZ congruent to angle YBZ from equation 1 and 2. So, segment AX will be parallel to segment BY because of corresponding angle test. Now move to the next further question. That is, in the adjoining figure, line touches the circle with center O at point P. Q is the midpoint of the radius OP. RS is the chord through Q such that chord RS is parallel to line S. If RS is equal to 12, find the radius of the circle. We have to find the radius of the circle. So let the radius of the circle be R, we can take it. Line L is the tangent to the circle. Line L is the tangent to the circle. That means segment OP is the radius. Segment OP is the radius of the circle. Therefore, segment OP is perpendicular to line L. That is which theorem? Tangent theorem. Therefore, chord RS is parallel to line L. It is given already. Therefore, QS is equal to Q. Perpendicular drawn from the center of the circle to the chord bisect the chord. That means half of RS it will be. So here half of RS, we have to write the formula, that is half of RS, and the reason behind it is perpendicular drawn from the center of the circle to the chord bisect the chord. So here half of 12 means 6. So also OQ will be half of OP, that is Q is the midpoint of OQ, OP, that means half of R. So in triangle OQS, what we can see? Angle OQS is 90 degree, that is OP is perpendicular to chord S. So we can use Pythagoras theorem over here. After using the Pythagoras theorem, you will substitute in place of OQ, the value will be half R. So you will solve it further and then you will get the R, that is equals to root over of 48, that is equals to 4 root 3. The radius of the given circle is 4 root 3 centimeter. Now come to the next part, that is the in the adjoining figure, segment AB is the diameter of the circle. Okay, with the center C, you can see it is the diameter of the circle with the center C, and PQ is the tangent to the circle which touches the circle at point T. Segment AP is perpendicular to line PQ. Segment AP is perpendicular to line PQ and segment BQ is perpendicular to line PQ. Prove that segment CP is congruent to segment CQ. So here again we will start from the given, that is C is the center of the circle, segment AB is the diameter of the circle, line PQ is the tangent, segment AP is perpendicular to line PQ and segment BQ is perpendicular to line PQ. To prove segment CP is congruent to segment CQ. So construction, draw segment CT, segment CP and segment CQ. Like this you have to join it. CP, CT and CQ is joined. So now we will start the proof, that is line PQ is the tangent to the circle at point T. It is given already. Therefore segment CT is perpendicular to line PQ. Why? That is tangent theorem. That is tangent theorem. Also segment AP is perpendicular to line PQ. Segment BQ is perpendicular to line PQ. It is already given. Therefore segment AP is parallel to segment CT is parallel to segment BQ is. So here line perpendicular to the same line are parallel to each other. So here you can see that property of intercepts made three parallel lines and their transversals. So here but AC is equal to CB. Why? Because of radius of the same circle. That means we can write here PT equals to TQ. So we can write PT equals to TQ. Then here in triangle CTP and triangle CTQ. In triangle CTP and triangle CTQ, these two triangles we can take it. From taking these two triangles, what we can make out? Segment PT is congruent to segment QT and angle CTP is congruent to angle CTQ. Why? Because each angle measuring 90 degree. And one common side you can see, that is CT. So these two triangles are congruent by the test of SAS. If these two triangles are congruent, that means segment CP is congruent to segment QC. That is by corresponding sides of congruent triangle. So hence it is proved. Hope you must have understood this till question number 10. The problem set 3 we have completed in this video.